All right, so get this. Even the smartest AI might not be as good at exploring as we are.
Interesting.
Yeah, so we're going to dive into some cutting-edge research from Georgia Tech that uses Little Alchemy, too.
Oh, wow. Using a game.
Yeah, you know the game.
Yeah, I know. Little Alchemy too.
Yeah, they use that to test how large language models, or LLMs, explore and learn.
Okay, so using a game to understand AI, that's a pretty clever approach, actually.
Yep.
Little Alchemy 2 provides like a huge space for exploration, right?
Right.
Hundreds of elements, thousands of possible combinations.
Yeah.
It's a great way to see how effective different approaches to exploration can be.
So you've shared some research with me, and it looks like they used data from actual human players, over 29,000 of them, and compared it to the performance of 4 different LLMs, GPT-4o1, and 2 versions of Meta's Llama.
That's right. They wanted to see how these AI models, stack up against us humans in terms of exploration and discovery within the game.
Okay, so were the AI explorers up to the task?
It's a mixed bag. On average, humans discovered 42 elements within the first 500 trials,
Okay.
with a total of 51 discoverable overall. Most of the LLMs fell short of that benchmark.
Really?
Yeah, Llama 3.18b, for example, only managed to discover about 9 elements.
Wow, okay, so who's a winner?
Well, there's one exception that really stands out.
Okay, lay on me.
The O1 model, it absolutely crushed it.
Wait.
Discovered 177 elements,
Wow.
far surpassing even the average human player.
That's incredible to see an LLM not just keep up with human players, but actually outperform them by such a significant margin.
Yeah.
What was it about O1 that made it so much more effective at exploring in this game?
That's the question, isn't it?
Yeah.
Researchers dug deeper into the data to analyze, the different exploration styles being used.
Okay.
They focused on 2 key strategies, uncertainty-driven exploration and empowerment.
So uncertainty-driven exploration sounds like it's all about taking risks.
Yeah, exactly. Like embracing the unknown and seeing where it leads.
Yeah.
A bit like choosing a path at random just to see what's down there.
So a lot of trial and error, maybe even some happy accidents along the way.
Exactly.
Okay, cool. So what about empowerment? How does that factor into the exploration process?
Empowerment in this context is about making choices that open up more possibilities for future exploration, even if those choices don't yield immediate results.
Got it.
It's about maximizing your potential for future discoveries, even if that means taking a less direct route.
So less about the immediate payoff and more about setting yourself up for success down the line.
Yeah.
Kind of like laying the groundwork for more extensive exploration later on.
Right.
Did the research show any differences in how humans and the AI models use these 2 strategies?
Absolutely. The analysis showed that humans tend to strike a balance between uncertainty and empowerment.
Okay.
We're willing to try new things, but we also keep an eye on the bigger picture,
Yeah.
making choices that'll benefit us in the long run.
So the humans
Wow.
are thinking ahead.
Yeah, most of the LLMs, on the other hand, leaned very heavily on uncertainty-driven exploration.
So they were all about that instant gratification of trying new combinations
Right.
without necessarily thinking about the long-term consequences or potential.
Yeah, that's a good way to put it.
Okay, so that brings us back to O1, our exploration all-star.
Right.
I'm guessing this model had a different approach.
You guessed it. What's remarkable about O1 is that it showed signs of understanding empowerment.
Oh boy.
Its choices indicated a preference for combinations that opened up more possibilities for future discovery,
Wow.
even if those choices didn't lead to immediate breakthroughs.
It sounds like O1 was playing the long game, thinking several steps ahead, just like a skilled human player would.
Yeah.
What do we know about what makes O1 unique? Could that explain its remarkable performance?
That's an area that researchers are still investigating, but it's likely that O1's training and development played a role.
Okay.
Unlike some of the other LLMs in the study, O1 is known for its advanced reasoning capabilities,
Yeah.
which might contribute to its ability to think more strategically about its actions within the game.
That makes sense. It seems like there's more to effective exploration than just brute force trial and error.
Yeah.
It requires a deeper understanding of the potential consequences of your actions,
Yeah.
a kind of foresight that might be tied to these advanced reasoning capabilities.
Right.
But what about those LLMs that struggled? Did the research shed any light on why they had such a hard time keeping up with the humans, let alone O1?
Yeah. To get a better understanding of what was going on inside these AI models, the researchers used a technique called sparse autoencoders, or SAEs.
Okay.
It's a way of analyzing the internal representations within the LLMs.
So it's like they were peering into the AI's brain to see how it was processing information during the game.
That's a great analogy, and what they found was quite revealing.
Okay, tell me more.
The SAE analysis showed that the signals related to uncertainty and choice were happening very early on in the LLM's processing,
Okay.
while the signals related to empowerment came much later.
Oh, so it's like they were jumping to conclusions about what to try next before fully considering the long-term potential of those actions.
Precisely. It's almost like they were thinking too fast, fixated on the immediate novelty of new combinations without giving enough weight to those empowerment-related factors.
That's a fascinating insight. It's not just about what the AI knows, it's also about how it processes that information, how it prioritizes different factors, and how quickly it makes decisions.
Exactly. And that brings us to a really important question. What would it take to design AI that can truly replicate human-level exploration?
Wow.
What kind of architecture or training methods would be needed to encourage that kind of thoughtful, strategic thinking that takes into account both the immediate and long-term implications of each action?
That's a great question. What an incredible start to our deep dive into the world of AI exploration. We've already uncovered so much, and I'm eager to explore even further. Let's see what else this research reveals about the future of AI and its potential to explore, discover, and maybe even surpass human capabilities.
Sounds good. Yeah, it seems the structure of current LLMs, might be predisposed to this rapid short-term thinking, which could be hindering their ability to explore effectively.
So it's not just about what the LLMs know, but also about how they process that information and how quickly they make decisions.
Precisely. And this raises an important question, like, what would it take to design an AI that can truly replicate human-level exploration?
Yeah.
What kind of architecture or training methods would be needed to encourage that kind of, long-term strategic thinking?
Like they're wired for instant gratification instead of that slow burn of planning and strategizing. So the researchers tried to give the LLMs a little nudge in the right direction, right?
That's right. They experimented with something called prompt engineering,
Okay.
where they tried to guide the LLMs by giving them more specific instructions or even hints about effective strategies.
So did it work? Did giving them a little coaching help the LLMs up their exploration game?
Unfortunately, not really. Even with more detailed prompts, the LLMs still struggled to break free from their tendency to focus on uncertainty-driven exploration.
That's surprising. You'd think that with a little guidance, they'd be able to pick up on those more strategic, empowerment-focused moves.
It seems that the challenge might be deeper than just understanding the instructions,
Yeah.
It might be rooted in the very architecture of these LLMs, in the way they process information and make decisions.
Okay, so prompt engineering was a bit of a bust, but the researchers didn't give up there, did they?
Indeed, they did.
What did they try next?
They actually tried to intervene directly in the LLM's internal representations.
Oh.
Those signals related to uncertainty and empowerment that we were talking about earlier.
Yeah, okay.
So,
That's getting pretty deep into the AI's inner workings.
right, remember those sparse autoencoders?
Wow.
The AI brain scans. Well, they used them to identify the specific neurons in the LLM that were most strongly associated with uncertainty and empowerment, and then they tried manipulating the activity of those neurons to see if it would influence the LLM's behavior.
So it's like they were trying to rewire the AI's brain,
Yeah.
making it more sensitive to those long-term strategic considerations. Pretty wild.
Yeah.
But did it work? Did tweaking those neurons change the way the LLMs explored?
The results were mixed. The interventions aimed at strengthening the uncertainty signal actually backfired, making the LLMs perform even worse.
Wow.
It seems like disrupting that early rapid processing of uncertainty threw them off their game completely.
Yeah, that's a good reminder that we're still in the early stages of understanding how these complex AI systems work.
Right.
Even seemingly small changes can have unintended consequences.
Exactly. However, the interventions aimed at strengthening the empowerment signal were a bit more promising, though they didn't lead to dramatic improvements in performance.
So it's like they were on the right track, but maybe they need a more nuanced approach to really crack the code of how to make LLMs think more strategically.
That's a good way to put it. This research is really pushing the boundaries of our understanding of AI exploration. It highlights the importance of not just achieving high performance, but also understanding the underlying processes that drive that performance.
And it also makes you wonder what the future holds for AI exploration. If we can figure out how to build AI that can truly think strategically and explore with that human-like intuition, the possibilities are endless.
Precisely to add another layer to this, the researchers also tested a different type of AI model in the study, a reasoning model called DeepSeek R1.
Right, so we've got LLMs, and now we're adding reasoning models to the mix. What makes reasoning models different?
Reasoning models, as the name suggests, are specifically designed to perform logical reasoning. They're often trained using reinforcement learning techniques that reward them for making logical deductions and finding solutions to complex problems.
So it sounds like reasoning models might be better equipped for this kind of strategic thinking that's so crucial for effective exploration.
That's the idea, and in this case, DeepSeek R1 actually did perform quite well, reaching near human-level performance in the Little Alchemy 2 task.
So it wasn't quite as impressive as LL1, but it still outperformed those other LLMs that were stuck in that uncertainty loop.
Yes, but what's particularly intriguing about DeepSeek R1 is that its reasoning process is visible. We can actually see the steps it takes to arrive at its decisions.
Wait, so it's like we can peek inside its brain and see the gears turning as it's figuring things out?
Exactly. And this is where things get really interesting because it gives us a glimpse into how the reasoning model is approaching the task differently from those traditional LLMs.
I'm on the edge of my seat here.
Yeah.
Give me the details. What kind of insights did they gain from analyzing DeepSeek R1's reasoning process?
Well, they observed that DeepSeek R1 was much less likely to repeat combinations that had already failed, indicating a more sophisticated understanding of the game's dynamics. And it also showed signs of considering those empowerment-related factors, though not quite as consistently as O1.
So it sounds like reasoning models might hold some of the keys to unlocking more effective AI exploration. But you mentioned that DeepSeek R1 wasn't perfect, right?
Right. While its performance was impressive, the analysis of its reasoning process also revealed some areas for improvement. For example, its reasoning pathways were sometimes convoluted and redundant, suggesting that it could benefit from more streamlined decision-making strategies.
Makes sense. Even with these advanced reasoning capabilities, there's still room for optimization. This is such a complex and rapidly evolving field.
Absolutely, and this research is a testament to the fact that we're just beginning to scratch the surface of what's possible with AI exploration. It's a journey of constant discovery, both in terms of the AI's capabilities and our own understanding of intelligence itself.
Well said. This has been an incredibly insightful look into the world of AI exploration. We've seen how different AI models approach this challenge, from the rapid-fire decision-making of LLMs to the more deliberate reasoning of DeepSeek R1, and we've learned that there's still so much to uncover about how to build AI that can truly explore and learn like we do. It's fascinating to consider the potential of these reasoning models like DeepSeek R1.
Yeah.
The fact that we can actually see its thought process,
Yeah.
to understand its logic and identify areas for improvement, that's a game changer in terms of developing more effective and transparent AI.
Absolutely, that visibility into the AI's decision-making process is crucial.
Yeah.
It allows us to understand not just what the AI is doing,
Right.
but why it's doing it. That level of transparency is essential for building trust in AI systems, especially as we start to deploy them in more complex and sensitive real-world applications.
And as we've seen with DeepSeek R1, even though its performance was impressive, there's still room for improvement.
Right.
The researchers noted that its reasoning pathways could be convoluted and redundant at times. It makes you wonder if there's a way to streamline that process,
Yeah.
to make its decision-making even more efficient and effective.
It's a great point. There's always a balance to be struck between exploration and efficiency.
Yeah.
You want an AI that can explore broadly and creatively, but you also want it to be able to zero in on the most promising solutions without getting bogged down in unnecessary steps.
It seems like there's a parallel here with human cognition. We're capable of both divergent thinking,
Right.
where we brainstorm and explore a wide range of possibilities, and convergent thinking, where we narrow down our focus and hone in on the best solution. Perhaps the key to building truly intelligent AI is to find a way to replicate that balance, that ability to shift seamlessly between exploration and exploitation.
I think that's a very insightful observation. The ability to balance exploration and exploitation is fundamental to intelligence, whether we're talking about humans or AI. It's about knowing when to keep searching for new possibilities and when to commit to a particular path.
This research has really highlighted that exploration is much more nuanced and complex than we might have initially thought.
Yeah.
It's not just about randomness or trial and error. It's about understanding the potential of different actions, about making choices that open up more possibilities, about balancing short-term gains with long-term goals.
Exactly. It's about having a sense of purpose and direction.
Yeah.
About understanding the context of your actions and their potential consequences. It's about being able to adapt and learn from your experiences to refine your strategies and become a more effective explorer over time.
And it's not just about building AI that can explore for the sake of exploring. It's about building AI that can explore with a goal in mind, to solve problems, to make discoveries, to push the boundaries of human knowledge and understanding.
Absolutely. The potential applications for AI-driven exploration are vast. Imagine AI that can help us develop new scientific theories,
Yeah.
discover groundbreaking mineral treatments, create innovative technological solutions, or even compose breathtaking works of art. The possibilities are truly limitless.
This research has been a truly fascinating journey into the world of AI exploration.
It has.
We've uncovered some surprising findings, challenged some of our assumptions, and gained a deeper appreciation for the complexity of building truly intelligent machines.
It's a field that's constantly evolving,
Right.
with new discoveries and breakthroughs happening all the time. And it's a field that holds immense promise for the future. As we continue to explore the frontiers of AI, we'll undoubtedly encounter new challenges and unlock even more incredible possibilities.
Thank you for joining us today on this deep dive into the fascinating world of AI exploration. We hope this has given you a new perspective on the potential of AI to not just mimic human intelligence, but to potentially surpass it in ways we can only begin to imagine.